let's start. Today the topic is salt analysis. Clear to you? Wait for a moment. Now, if anyone asks you what is salt analysis, it's very simple. To analyze a salt, to analyze a unknown salt, if it is unknown, is known as salt analysis. Now the question arises, what to analyze and from where we get the output? That is the question mark. I am taking an example. Look at what I am telling. As we all know, when acid and base combines, clear to you? Listen carefully. When acid and base combines, they form salt plus water. It is a general reaction. We are very much familiar with this reaction. If I take an example, suppose if I take AgOH as a base and HCl as a acid, then tell me what will happen. This one is base, don't get confused, this one is base and this one is acid. Now what will happen, check it out. It gives you AgCl simple plus H2O. That is, this AgCl is salt. Now if you do not know that there is a salt AgCl, unknown. Now if anyone asks you to find the acidic and basic radical, to find the sample of the salt, what to find? Look at AgCl has two type of ion, Ag plus and Cl minus. That is, in salt analysis we find cation, we find anion. That is, the process of detection of cation and anion from the unknown sample of a salt is known as salt analysis. Clear to you? In salt, what to detect? Cation and anion. So the complete definition of salt analysis is the process of detection of cation and anion from an unknown sample of salt is known as salt analysis. Clear to you what I am telling? Listen carefully. The process of detection of cation and anion from an unknown sample of salt is known as salt analysis. But sometimes we hear that find acidic and basic radicals from unknown salt. What does it mean? What is acidic and basic radical? We are very much familiar, that is cation and anion, but from where we get acidic and basic radical? That's the question. Listen carefully. If I talk about the Ag, Ag comes, this Ag linked with base, so this Ag comes from a base. So cations are nothing but a basic radicals. Clear to you? Because the cations of salt comes from base. Now this one is Cl and here is Cl. This Cl comes from an acid. So anions are nothing, just acidic radicals. Clear to you? Clear, friend? If you have any doubt, you can approach to me. I am starting with a basic level so that you can easily identify, so that you can easily go through the chapter. What I am telling? If anyone asks you, then you can say cations are basic radicals. Clear, friend? And anions are acidic radicals. Acidic radicals, because we get cations of salt from base and anions from acid. I am taking one more example. Lots of examples are there. If I write here NaOH, clear to you, plus HCl, you can easily estimate that it will give you NaCl plus H2O. This one is cation, this one is anion. This cation comes from the base, so this is basic radicals. This is anion, this anion comes from acid, this is known as acidic radical. Lots of examples are there. If I talk about AgOH, PbCl2, Hg2Cl2, clear to you? Many examples are there. These all are the examples of salt, and this one is cation, and this one is cation, this one is anion, and this one is anion. Clear? Now the question arises, how to estimate cations and anions? But before that, we have to differentiate salt analysis. Further, salt analysis are differentiated into two types. What are the types? Wait for a moment. That is, first one is qualitative and the second one is quantitative analysis. Clear? Qualitative analysis, clear to you? And the second one is quantitative analysis. Clear, friend? Qualitative and quantitative analysis. Now, if anyone asks you what is qualitative analysis, to identify the sample component. What I am telling? To identify the sample component from unknown sample is known as qualitative analysis. What is quantitative analysis? To find the quantity, of the sample, that is known as quantitative. That is calculation based, theory based. Clear? Now, what I am telling, friend? To identify the sample components from unknown sample. Clear to you what I am telling? To identify the sample component, that is cation and anion, from unknown sample means unknown salt. Now, quantitative, completely calculation based. To find the quantity of the unknown sample is known as quantitative analysis. Clear to you? Now, we have to discuss qualitative analysis, because this is completely calculation free and this is involved calculation. Clear? How much quantity? You have lots of method to find out the quantity. I have discussed it earlier, but here first time I am going to discuss this one, qualitative analysis. Sometimes we people think that it is a theory chapter, we need lots of effort to study, to memorize all the radicals. No, friend, it's not that much tough. It is so much easy. You have to follow certain tricks and techniques. You can easily find out the output. I will provide you useful information related to the qualitative analysis, and we'll discuss previous year questions also, so that you can go through the chapter very easily. Clear? But we'll move slowly because it is one of the important chapter. I think now you are very much familiar with the topic, that what we are going to study in this chapter. Again I am repeating, if anyone asks you salt analysis, it's very simple. Listen carefully. To analyze a salt, what to analyze? Because as we know, a salt contains cation and anion. So if we want to analyze a salt, we have to analyze cation and anions. Clear to you? Now lots of cations are there, like Ag plus, Pb2 plus, Hg2 plus. Then if I talk about anions like HCO3 minus, CO3 2 minus, F minus, Cl minus, Br minus, lots of examples are there. So to identify cation and anions, this is known as salt analysis, that is to detect them from the unknown sample. This is completely practical based chapter. In laboratory work, in laboratory classes, you have seen lots of practicals, you have done lots of practical on this topic. Clear? Now salt analysis are of two types, that is qualitative, and the second one is quantitative. Qualitative, completely qualitative, calculation free, that is to identify theoretically the sample component. What is quantitative? Completely calculation based, to analyze, to find the quantity of an unknown sample. It is known as quantitative analysis. We have various methods to find the quantity, but now I have to focus, we no, not I, you have to focus, and we together have to focus on qualitative analysis, that is to find cation and anion. Cations are basic radicals, anions are acidic radicals. Why cations are basic radicals? Because cations comes from base and anions comes from acid in case of salt. Now friend, I am moving here. I am going to discuss the next thing. Now the question arises, further qualitative analysis classified into two types. That is how to do qualitative analysis. That is, first one is wet test and the second one is dry test. Clear to you? That is, first one is wet test. Wait for a moment. First one is wet test. And the second one is, friend, wait for a moment, dry test. Clear to you? We will discuss one by one. Wet test and dry test. Now the question in wet test and dry test like flame test. Do you remember this? Charcoal cavity test, sodium carbonate bead test, borax bead test, lots of examples are there. Generally it is we sometimes found in book, that is dry test for basic radicals and wet test for acidic radicals. Not like this, it is just a general things. Now these are the two tests. Now the questions is, if we have a sample of salt, what I am telling, if we have a sample of salt, that is it contains cations as well as it contains anions. Am I right or wrong? Sir, you are right. Now what to find before? That is what I am telling, whether we need to detect cations or whether we need to whether we start from anions. Tell me. If I talk about AgCl, first of all, here it will break like this, Ag plus and Cl minus ion. So in this case, in each and every case, first of all we have to detect the anionic part, then we will move towards cation. If anyone asks you, if you ask me, why sir? Wait for a moment. Why? Because there are some interfering anions which interfere in the detection of cations. What I am telling, we have to detect anion first during the salt analysis, because there are some anions, like if I talk about fluoride ion, if I talk about phosphate ion, if I talk about borate ion, these are some interfering anions which interfere during the detection of cation. So it's better or convenient to detect the anion first, then move towards cation. Clear to you what I am telling? Listen carefully. Wait for a moment, give me a few seconds. So what I am telling, again I am repeating, if I have a sample of salt, now we have to detect cation as well as anion. We will start from cationic side, we'll start from anionic side. That is, we have to detect first anion, then we will detect cation. What is the reason behind it? Because there are some interfering radicals, some interfering anion which interfere in the detection of cations. Clear? Now I am restricting our analysis for anions, then we will move towards cations. Clear to you? Now anions and cations are further divided into different parts, different categories. But again I am telling one thing, there is no such method, there is no such proper scheme to identify to categorize them. What I'm telling, it is just for convenience, it is just for our convenience. Listen carefully, again I am repeating, there is no such scheme or method to categorize anions as well as cations, but only for our convenience we are doing this. No theoretical as well as basic practical explanations are there. Clear to you? So now, how to differentiate cation and anions? Cations are categorized into 6 categories, that is from group 0 to groups 5, that is group 1, group 1, clear to you, group 2, group 3, clear, and so on. We will discuss this one by one. Group 4, group 5. Okay. Now, if I talk about anions, it is further classified into 2 types. Now, first of all, we have to discuss on this. Clear? If I talk about few anions, that is F minus, Cl minus, remember this, Br minus, I minus, CO3 minus, HCO3 minus, then H2O3, 2 minus, H2 minus, clear to you, HS minus, clear friend, that is NO2 minus, that NO3 minus, then SO3 2 minus, clear, then HSO3 minus, SO4 2 minus, clear, SO4 2 minus, then there comes, tell me, that is BO3 3 minus, PO4 2 minus, that is F minus, that is C2O4 2 minus, clear, that is now C2O4, now there comes CS3 COO minus, clear. These are the various anion, and we have like one more. I am giving one more also, that is MnO4 minus, Cr2O7 2 minus, clear, CrO4 2 minus, clear to you, MnO4 2 minus. These are various examples. We have to detect these anions, clear to you. Now these are categorized into 2 different classes, and these 2 different classes are further divided into 2 different subclasses, and we'll discuss one by one. First of all, we will do basics test, preliminary test, then we'll do secondary test. Clear to you? Now moving here, friend, Wait for a moment. Clear? Now, the topic is classification of anions. Clear? It can be classified further, that is anions are also known as acidic radicals. Clear, friend? We have to identify, we have to judge, we have to categorize the anions, that is acidic radicals. Clear? Now, how to categorize them? First of all, there are two methods. Clear? Wait for a moment. The first one is anions, those anions which on treatment, what I am telling, listen carefully, anions which on treatment with acids give volatile compounds, or you can say give volatile component, or you can say gives volatile product. Clear? What I am telling, first category is anions when treatment with acids give volatile compound, volatile component. Volatile means like gases, like effervescent. Clear to you? Now, I am moving here. The next one is anions which on treatment with acids give non-volatile compound, or you can say non-volatile component, or you can say non-volatile product. Clear to you? This one is non-volatile. Clear? Now, these are further classified into two types. Clear, friend? These are further classified into two types. The first type is, wait for a moment, give me few seconds. That is, the two type is group 1, or you can say here group A. Clear to you? I am not following the bookish knowledge. That is group 2, and the second one is group B. Clear, friend? So, again I am repeating, do not remember this chapter, just follow and think how to proceed. Clear? Few things just we have to keep in our mind, otherwise it's so easy. Look at group 1 and group A. How to classify this further classification? That is group 1 and group A. Now group 1, on treatment on treatment with dilute acid like dilute HCl, dilute H2SO4. This confirms its presence. And which type of anions is treated, which type of anions gives positive treatment with dilute acid, and the group 2 is classified as on treatment with concentrated acids like concentrated HCl and concentrated H2O, gives positive reaction. Now in first case we have to treat salt with dilute HCl, that is because we get anions, we are getting anions from salt. So which anions are positive for dilute acid and which anions are positive for concentrated HCl. Now it is found that there are few anions which are positive for, which gives a positive reaction with dilute HCl and dilute H2SO4. These are, look at what I am telling, is very easy to memorize, or sorry, to keep in mind, not to memorize. If I think that we need to memorize, then it may be tough. So we are just changing the word only, okay friend. So here that is carbonate, bicarbonate, carbonate, bicarbonate, sulfite, bisulfite, carbonate, bicarbonate, sulfite, bisulfite, thiosulfate, sulfide. Then there comes acetate, nitrite, acetate and nitrites. 8 people are there, that is 8 radicals are there. What I am telling, friend, listen carefully. Carbonate, bicarbonate, sulfite, bisulfite, thiosulfate, sulfide, that is acetate and nitrite, not nitrate, nitrite. This is the class group 1, group A class. Now if I talk about group 2, then in this case there comes Cl minus, chloride, bromide, iodide. Clear? Cl minus, Br minus, I minus. Clear to you? Now tell me what will come. Tell me friend. Chloride, bromide, iodide, nitrite, NO3 minus. Clear to you? Now there comes oxalate, C2O4 2 minus. This is the 2 subclass: chloride, bromide, iodide, nitrite, oxalate. Clear to you? Now if I move here, it is again further classified into 2 types, that is group 1 and group 2, or class A or class B. If I further classified them as a class A, and this one is class B. Clear to you? Now classification based on the reaction. Class A radicals, anions, give PPT reaction, precipitation reaction. Clear to you? And class B gives favorable redox reaction, that is I am talking about oxidizing and reducing agent. Clear to you? If I talk about friend MnO4 minus, carefully listen carefully, MnO4 minus redox reaction, powerful oxidizing agent, Cr2O7 2 minus, CrO4 minus. Clear to you? Then there comes MnO4 2 minus, so on. This is the class What I'm telling, this is the class B, that is based on redox reaction. Clear to you? Now if I talk about class 1, that is which gives precipitation reaction, we people know. If I talk about borate, if I talk about phosphate, if I talk about fluoride, these all gives PPT type reaction. If I talk about sulfate, this all gives PPT type of reaction. So these are the classification according to me. That is, acidic radicals are further classified into 2 types. That is what I'm telling, according, first of all, treatment with HCl, dilute or concentrated HCl. If dilute HCl, then the categorize, that is carbonate, bicarbonate, sulfide, bisulfide, thiosulfate, sulfide. This one is acetate and nitrite. And with concentrated acid, that is Cl minus, chloride, bromide, iodide, nitrite, oxalate. Now the second classification, if on treatment with acid not give volatile product, that is it gives non-volatile product. Now it has 2 type, PPT type reaction and redox reaction. We people all know MnO4 minus, Cr2O7 minus, CrO4, MnO4 2 minus, so on. And class B, PPT type, like borate ion, phosphate ion, fluoride ion, sulfate ion, these all are the PPT type of reaction. Now we'll analyze the second, analyze each and everything, how to find out carbonate, bicarbonate, how to find out chloride, bromide and iodide. Clear to you? But first of all, I am giving you few seconds to note the entire table. So let's move to next one. First of all, now we will focus on this term. Wait for a moment. This one. Clear? Now I'm going to rub. Clear, friend? Now let's start the battle. Now first of all, we have to check that group 1, group class A, or we can say group A, acidic radicals. As I told you on treatment with dilute HCl, how to identify, look at, I am starting with carbonate, CO3 2 minus. On treatment with dilute HCl, tell me what will happen? Sir, it gives CO2 gas. Clear? So if a salt contains carbonate ion, we do not know, but it is if there is a mention, it is a group A class, that is treat with dilute HCl. If it gives CO2 gas, then we can say the radicals, the anionic radical is, or the acidic radical is carbonate. Now if I talk about HCO3 minus plus dilute HCl, it again give CO2 gas. So friend, here is a big confusion. Now in both the cases CO2 gas is a product. Now how to identify which one is carbonate and which one is bicarbonate, that is whether the radical is carbonate or bicarbonate, because in all the cases the CO2 gas is the output. So in this case again further layer classification is there. I will discuss it later, but I am giving you a simple idea. If I talk about bicarbonate, it is water soluble. What I am telling, it is water soluble, that is it does not give precipitation reaction, it does not give PPT reaction. Clear to you? What I am telling, if a salt containing carbonate and bicarbonate, then on treatment with HCl, it gives carbon dioxide. Now, in both the cases, the gas is carbon dioxide. Now, how to identify them? If a salt containing the bicarbonate radical, that is, it is water soluble, that is, it does not give PPT reaction, precipitation reaction. But if I talk about carbonate, if a salt containing carbonate, then it gives PPT, precipitation reaction. This is the second layer of detection between carbonate and bicarbonate. Now one more thing, how to identify carbon dioxide? We people know this is colorless gas, this is odorless gas, and it evolved with brick effervescence. That is like this. If this is a pot, it will like this, it will evolve like this. Clear to you, friend? This is brick effervescence. So how to judge then? That is, the gas evolved, wait for a moment, is colorless, odorless, or evolve with brisk effervescence. Clear to you? Now, how to layer them? One gives PPT reaction and one does not give PPT reaction. What is PPT reaction? Check it out. If I write here carbonate, clear to you? Wait for a moment. This one is carbonate. Now, if I treat it with Ca2 plus, if I treat it with, wait for a moment, Ba2 plus, if I treat it with Sr2 plus, then what will happen? Do you remember this? Then in this case, it forms white PPT, CaCO3, this is the precipitation reaction. It forms again white PPT, BaCO3, it forms SrCO3, again white PPT, again treatment with, if treated with Pb2 plus, then what will happen? Tell me. Wait for a moment. This is the second layer detection. Pb2 plus, it gives PbCO3. Clear to you? This is again a white PPT, which on further treatment, that is, it gives PbCO3 into PbOH whole twice, that is basic lead carbonate. This one is, do you remember this? Basic lead carbonate. I have discussed this reaction in P block, in chapter P block element, basic lead carbonate. Clear to you? That is, these all are white PPT. This confirms the presence of carbonate ion. Now again, on treatment with, tell me, on treatment with Ag plus, it gives Ag2CO3, it is again a white PPT, which on further boiling decompose and gives you Ag2O plus CO2. Lots of reactions are there, no need to be worried. Just think on it. PPT, that is treatment with radical, Ca plus, that is CaCO3, Ba2 plus, BaCO3, Sr2 plus, SrCO3, Pb2 plus, that is PbCO3, so on. That is with Ag plus, that is Ag2CO3, then which on further boil give Ag2O plus CO2, again which on further heating decompose to give Ag, and this is black silver. Clear to you? These, now I think you can easily differentiate carbonate and bicarbonate radical. Clear to you? Just follow the simple techniques, layered techniques, move one by one, then definitely each and every chapter will be easy for you. Clear to you, friend? So time is calling, time to say bye bye. In my next class I will discuss few more things. Thank you so much. Bye bye.